In this video, we will work through the following example problem. A motorcyclist is driving along the ground when they run into a parked car. They fly through the air a distance 125 meters before they hit the ground. Your job is to find out, was the motorcyclist speeding when they ran into the parked car? To solve this problem, we will use the concepts of projectile motion, specifically, we're going to use the range equation because we don't care about how long he was in the air. We only care about his initial velocity when he flew 125 meters. We will go ahead and write down the range equation, which has that it depends on the square of the initial velocity, it is divided by the gravity, and it depends on sine of twice the initial angle that he flew off at. If he flew off at angle theta, then we need to know that to find the initial velocity. We will go ahead and start out by writing the range equation. We have that the range is equal to to the initial velocity squared divided by the acceleration due to gravity, then times sine of twice the angle that he flew off at. So if I draw in a probable trajectory, I need to know this initial angle theta and able to find the initial velocity. I'll go ahead and do that right now. Now, since we don't know this initial angle, we can't for sure say what the initial velocity is. But let's carefully reread the question. The question was the motorcyclist speeding? Not, what was his initial velocity? Was he speeding is a slightly different question. It is this initial velocity greater than or equal to the speed limit, which here is 60 miles per hour. So, to do this, we can answer it because we know that this sine function here will take on a maximum value at theta equals 45 degrees, which means that this initial velocity will then get a minimum value at that same 45 degrees. If this initial velocity, the minimum possible initial velocity, is greater than 60 miles per hour, we know that the motorcyclist was speeding. So let's go ahead and do that calculation. Vi is equal to the square root of 125 meters, 9.8 meters squared, meters per second squared, divided by the sine of twice 45 degrees. Going through that, we get that we have 35 meters per second as the initial velocity. We need to turn meters per second into miles per hour. To do that, we will go ahead and go through with a full conversion. We know that there is 1,000 meters in 1 kilometer. We know that there are 3,600 seconds in 1 hour. And a quick Google will tell us that there are in 1 kilometer, there are 0.621 miles. Going through, finishing this calculation will give us 78 miles per hour, which is greater than 60 miles per hour. And so, was the motorcyclist speeding? The answer is yes. Yes, he was.